Hello, welcome to my video. In this video, I'll give you a short introduction to my demo project where I try to detect the cyclists for drivers so that the both party is safe and let the driver knows where are the where are the cyclists. Uh, in this video, I'll talk about basically what I did exactly, share my experiences while doing it and how I did it. And at the end, I'll give my finding out what can be done, in that perspective. So, but I will first start the project in this website. Exactly, this is a demo website where I display the project, the idea, how the model looks like, how it does what it does, and also at the end there's a interactive part where you can also play with the model and try it with yourself. But before getting into this video, I would like to introduce myself. My name is Fatih. I'm a student of Masters of Data Science in Oldenburg University. Uh, so, all right, yeah, that was it. That was me in a nutshell. So, okay, I'll start with this. By the way, before not mentioning it, that my interests are deep learning, machine learning, and computer vision specifically. So, okay, now we can start. So this is I chose the Yolo model because I had used it before. So I thought it's going to be easier for this demo, at least for this demo project. So it's an open source model. I think this is very nice from a Analytics company, and it's very easy to use, easy to integrate. And I use the RoboFlow bicycle data set in this thread. You can see. Uh, that's also is very was very easy to integrate and use in my code base. So basically, in this project, we try to detect cyclists and then take a look at the distance of it. Try to detect the distance of it, and let the driver know if the distance is under 2 meters. I mean, 2 meters is like optional. Like it could be 1 meter, it could be 1.5 meter, whatever. We just need to indicate it. We need to give a warning to the driver so that he or she knows where the cyclist is. And I also integrated a tracking algorithm with the bike track algorithm. Is that also nice to have? All right. In distance calculation specifically, I use very simple logic and it works perfectly. Okay. And we see here some examples of the model's output. Here we see 5 cyclists and it detects them perfectly. In this picture, we have a bunch of cyclists, one in another. Uh, so we see that the model can detect 3 of them, but couldn't detect some of them, which is perfectly fine because it's not a very comprehensive trained model. Uh, I think this video is interesting. So here we see that he already detected the cyclist and he gave them IDs. That's the tracking part of it. Now they always have the ID of their own. So maybe now tracking them. So we see that it's a green bounding box. But let's see how it goes at the moment. See that the one in the front gets into red because he's in the border under 2 meters. He's in the threshold under the threshold. So in this scenario where the driver knows there's a bike nearby, so uh, that's a good part. Here's another video. Again, we see the IDs, detections, and everything. Here you see that the model kind of confuses this part with cyclists. I mean, this could be with a lot of reasons. I don't know why exactly. It's very interesting. Uh, but it just does what what it does, but that can be prevented, I think, with a lot of data. We need to we need to have comprehensive of data, right? And at the end, you can give it a shot by yourself by just let's try our own. I just uploaded a video. I'll upload a picture, and here we go. I just got to output. It just detected that cyclist or a video. I'll give a video. Where is that video? Okay, it's here. All right. Usually video takes a bit more time, so let's give this app, really small app, a bit time. While that's being detected and being processed, I want to go to real quick the GitHub page. This is the GitHub page. I'll be sharing all the links in the description part, so you can take a look at and fork this GitHub page repo and try it yourself, do something, change something, whatever. And I also would like to go to my working environment, which is Google Colab. I did everything here in Google Colab, then integrate it to Python file into the Streamlit app. And here I would like to show especially the model evaluation metrics. Here we see that I'm training the model in Yolo 11 Nano version and 10 epochs. And here we see the confusion metrics. It can be seen that we are sometimes detecting wrong the backgrounds as the cyclists. Most of the case, sometimes the people are getting a cyclist, or some bikes are getting cyclists. So I think that's a good point to mention. As it's a part of my finding out part. So maybe we'll have more cyclists and people, so that the model knows the difference between a person and bike and the cyclist. And sometimes we are predicting the cyclists wrong. We're not predicting them, basically. This can be, I don't know, light, background. Maybe it's really hard to see. There's a lot of reasons, but obviously we need to do more investigation to that. So, all right. So here, in this graph, we have some metrics. Especially we are interested in with the bounding box regression loss. You can see that the model converges very well. Even in 10 epochs, we will need to do more epochs for the model to converge better. But the validation part, this was the training part. The validation part is, yeah, kind of gives a signal of flattening out, but obviously we need to try it more to see that, try more epochs to see that. Specifically, I would like to talk about precision and recall and F1 score. In this scenario, we would like to detect all the cyclists, right? Precision on its own is not going to do it for us, and the recall is not going to do it on its own for us. So we need good combination of that, and that's what F1C core. F1C core. And here we have a beautiful image, I think, where it shows in the confidence level of 0.381, we have the highest F1 score. And I think this graph is really doing a good job for informing us about the confidence level, the trade-off between recall and precision. So, all right, yeah, that was that part I would like to mention. And there are other images that can be looked at. You can look at it on your own. And this is a sample image with labels, true labels, and the model's prediction. Okay, maybe we can reconnect model. Okay, anyway, it's not important. And here we see that I just there's some code chunks where it detects the picture, so we see that there are four people and it detected them perfectly fine. Yeah, this was the image in the web app, and this one is the video. This is the video with tracking and everything. You can look at the code chunks on your own. So here we came to the end. So again, data augmentation and refinement is very important, because what we give as data to the model, it will get, and it will kind of adjust itself to that. So it's important to give smart data sets. There are certain scenarios where we want to model not to fail, like this. When the car is turning right, it's really hard to see. It's kind of like in a dead spot. The driver here is kind of having a hard problem to see this bike, for example, cyclist. So in these scenarios, we don't want to fail, and maybe we could have more data set in the scenarios, or scenarios like this. So, okay, this is the end of this part. we're done with this part. So if you remember that the Stream app, we have already put a video, so we can see that it has already been processed and it's ready to download. So, but before that, let's look at the raw video. The raw video is just a person that's riding bike and their bikes get there around him. So this is a good, I think, video. Let's take a look at the raw video and download it real quick. All right, download it, and let's look at the output now. Yes, you can see that it has already detected two bikers and then gave them the IDs, and the distance looks okay, looks nice. And okay, another biker has already detected that too. So good, looks good. All right. So these are all things that I wanted to share and put in this video. So if you have any questions, first of all, thank you for listening to me and being interested in this video. I will suggest you to go to this website and to try it out with yourself on yourself. And thank you very much. If you got any questions, you can always ask me through these links I'll be mentioning in the description. So thank you and have a good one. Bye bye.